start the recording. Perfect. All right. Welcome everyone to our second speaker event of the year. We're really lucky and very honored to have Mr. Janesh Chhabra, a senior engineer at AWS, here to speak to us today. I think there's a lot of great value that we can get from him today. So, yeah, without further ado, Janesh, if you want to give yourself a bit more of an intro, and we can get right into it.
Cool, thank you. Yeah, so my name is Janesh. I'm here to talk to you today about AI and machine learning used in production at the various companies, places I've worked at, and consulting I've done. All the images here are created by this text for image to image, which is a custom model I created. So for those that know, there's usually text to image, but text for actually involves two text transformations in order to take raw text, make it better for image description, and then image to image separates background and foreground so that the image comes out better. But yeah, it's not a very great model, as you'll soon see. To start, a bit of a background at where I've been and what kind of things I've done, and then we'll kind of like go through the various subsections that I try to group things in. So at first I first actually did research at UCSC, forecasting renewable energy. And then I went and I got a job at Amazon forecasting. And over here, I was responsible for forecasting demand. After that, I was actually going to get my master's, but I was doing a master's while working, and then I decided to drop out of the master's because I was taking too long and too much of my time, and I switched teams as well to the Amazon Data Lake, and then switched teams again to AWS. And then after that, I left the company. I was like, screw working for large companies, and I went to a startup called Definity, which was building like a decentralized cloud, basically for it's just a place where you can run your programs. And the idea is that a bunch of smaller data centers run their stuff, and they were trying to compete with AWS. But over there, the CEO kind of started to go crazy and started firing entire orgs because he thought we were planning a revolution against him. He also moved away from the US, and he moved to Switzerland. And so I got worried that he was going to fire all of US. So I went back to AWS. Along the way, I've been consulting as well. Some privately, some are more publicly. And besides for that, I also have some open source projects, which some companies use and some are kind of very much in flight. So to start with, we'll start with forecasting. This is not an image of me, just something the model decided to create. So things I've done is, as I mentioned, I've done forecasting renewable energy for power grids, and then I moved into forecasting prime, and then some ingestion stuff, which you'll be surprised there's a lot of ML used there as well. Yeah, so I started my journey like many of you all at UCSC, and one of the professors posted an opening for looking to forecast renewable energy. And essentially what I did there is evaluated a lot of techniques, and we We presented at some conferences, and we were writing a paper. But ultimately, my goal was to get a production power grid to use our techniques. And the goal is like what we want to do is power grids can have a mixture of renewable energy and non-renewable. But renewable energy, like solar, if there's like clouds, starts producing less output. And what you need to do there is you need to ramp up like your nuclear facilities or fuel-based facilities or whatever, so that your grid energy is stable. And you need to predict renewable energy in the future so that you can know when to switch up and down, like optimally. So first we failed due to windowing. Our windows were too small, and it was causing too much, like the generators could not be turned on in time. Like we would give them a 12-hour notice, but it would frequently take up to 36 hours to spin up generators. Who knew? After that, we improved our windowing again, but the margin of error started being too high to where like a lot of power grids were like, screw you guys. We're just gonna keep it as we were before. And nobody used it. And yeah, it was quite sad. And that's also why I decided to leave my master's at some point too, because I realized that yeah, in a lot of cases, sometimes people just kind of face like chase publications and stuff rather than real world. And I wanted to work on more real world use cases where it would actually eventually work. So yeah. By the way, feel free to interrupt with any questions as well.
Yeah, I'll be monitoring the chat as well. So if you guys have any questions in there, I'll pull them together. And I'll we can go from there if that happens.
Cool. Yeah. One thing on the test is I purposely kept things very vague on the slide content because I'm not legally allowed to disclose quite a few things. Yeah, like this one. After that, I went into forecasting for Prime, Fresh, and Whole Foods. Our goal here is Prime, Whole Foods, etc. They all have like a bunch of physical, what we call them is distribution centers, which host a bunch of goods. And basically, different people, different areas order different things, and we want to predict what will be there and have them in stock at a distribution center close to you, so that like the right things can be ordered, and it costs Amazon less to deliver them to you when needed. And a 0.01% gain here could literally mean the difference in like, you know, hundreds of millions of like actual margin. So it's a very cool core model. And before I joined the existing system, I was asked to improve mainly the runtime. And one step in the existing system took 2 to 5 hours to run. And it uses Poisson distribution over the entire data set to estimate global demand. Now you have to realize like the entire data set is like the entire order history since Amazon existed, like literally since the 2000s. So we're talking like petabytes of data. It's loading into memory, and we're trying to create Poisson distributions over at yeah, it just results in a situation where like most of the data is probably worthless, like not really needed. And the second thing is like, if I'm predicting, you know, the capacity, for instance, for San Jose or Santa Cruz, California, right? is the data from like Canada really helpful? Um, so I experimented with a lot of things. Like I trained seasonality curves, which is basically taking data and seeing the seasonality of certain items. For instance, um, like if we talk about sweaters, right? Sweaters are going to be ordered in the winter. And if we talk things like ice makers, they're going to be ordered in the summer. So we want to basically train curves over a period of time, which lift or lower certain demand. Yeah, so this helped us maintain accuracy while trimming our window to only look at the past 6 months of data. But it still took 2 hours to run, so it was pretty bad. So I was like thinking, I'm like, we only care about hyper localized areas technically. What if we just took the median or like a percentile and just estimated demand on that when items are out of stock to get the current demand. And then we pass it to our later downstream models to do the actual forecasting. Would that reduce our time? And this is what's known as a heuristic. So I'm replacing like a whole subset of like complex ML algorithms with a heuristic and then using a model later to do the general forecast. And this quick math basically ran in 1 minute instead of 2 hours. And it increased accuracy by around 4%, which is huge for us. When I took these results to people, they were like, something must be wrong. But it turns out like if you pre-process like very efficiently, like with heuristics, like it creates a very consistent basis so your core models can forecast better. So you don't need models on top of models. You can use heuristics to improve your input and then do models. And yeah, and the main question I got was, how are the bananas? So for reference, the number one ordered item on Fresh and Whole Foods, and one of the things that keeps delivery there coming is bananas. Literally, if a banana is out of stock, around 40 to 50% of the order volume could drop. That's how vital bananas can be. So I had to check that the bananas were okay. And I also had to validate my findings with a banana on call, which the LLM decided to depict here. But yeah, it was a fun lesson in terms of like sometimes things are often overcomplicated and we can simplify a lot of things with a heuristic, especially in like super complicated forecasting systems. People tend to just add models and then another model and then another curve and then a model and then a model. And there are often opportunities where you can just take a whole portion of it and be like, can this really be replaced with a heuristic or some quick math or something like that? Yeah. Any questions on forecasting before we move on? I think right now forecasting is in an interesting space because the state of art forecasting models have become super underrated or not paid attention to in favor of Gen AI. But think there's a lot of room for improvement. Well, if not, we'll move to anomaly detection, which is something I did at EBS and at Dfinity. So at EBS, for those that don't know, if you have a computer, you usually have a hard drive, which is what you store data on. Usually, these days it's an SSD. So for cloud, we basically made a replicated network attached SSD, which is just a fancy hard drive for your cloud computer. And the idea is that it fails less than your SSD would. Like, it's more reliable. Problem we started seeing is when I joined there, why I was hired and why they asked me to join, what they wanted me to fix is we're seeing issues where we're creating code and improving reliability, except in production, customers just keep complaining about lack of reliability. And so I had this idea. I don't know if anyone follows Netflix, but they pioneered this idea of chaos testing. And I thought, I think really what we need here in testing and in production, and in order to figure out what's actually going on, is just inject chaos. However, injecting chaos only works if we're able to figure out what goes wrong after. And if you inject chaos, what tends to happen is like you just see a bunch of log spew and you don't really know like what is going wrong where, especially in these large systems, which are like, huge distributed systems. Like at EBS, there were maybe 150 services performing interconnected calls just to like perform one action, which you would in a UI, which is like, create volume. So if you inject chaos, like let's say turn off the network to a place, or start rebooting a bunch of servers, or just take a whole bunch of things offline, start dropping volumes, things like that. You don't know what services will start failing where, and even if they do, you don't know which are those services. So it's like finding needle in a haystack, right? You're trying to find what the chaos impacted, if it impacted something, why. And one of the main things is we can't have supervision. Like, people can't be sorting through logs, labeling them. Like, nobody has time for that. So I worked on a system which essentially would index logs from a bunch of different services and then create like cluster them based on patterns during injections, and then we would show the highest based anomalies. And this is usually an area where you don't actually use anomaly detection. Like, who uses anomaly detection to test, or who uses anomaly detection to benchmark in production? But like the whole org is just software engineers, right? So luckily I had ML expertise and I had taken ML classes and other things like that. I was pretty familiar with the literature. So I decided to apply it. And the results were like, we improved our reliability by, so we were tracking close to like 99, and we improved to 49, so 99.99 for our new offerings. And it's a pretty big win. Like, how to quantify that is like 99, I believe, refers to like having an entire 2 days or so of downtime, and 99.99 is just 3 minutes or 5 minutes or something like that. So In absolute terms, it may not seem like much, but yeah, if you're talking for a customer where you basically have volumes down for over a day versus like just a few minutes, like yeah, it makes a huge impact. After that, I moved to the startup called Definity, and I don't even know what they hired me for because I ended up just doing random stuff. But we were creating a scalable cloud. The problem is there are nodes from a bunch of different data centers. And imagine you're in a data center and you find out that your nodes are powering a bank, right? And like you're a low level employee and you're like, I want to take their money. Like you can, there's a lot of attacks a node could feasibly do, right? Like you could try to, for instance, uh do something like a DOS where you like emit a bunch of bandwidth and network traffic to slow down the bank or take it down. Um, that's just if you hate them. But if you want to steal money, you could do something uh like spam them with transaction, taking money from somebody else's account and adding it into your account, right? And all you would need to do is you can actually get an encrypted payload. Because you own the node, you can snoop all of the payloads. You could find the transaction which actually added money to your account, and you can spam that. And obviously, one thing is we do not want malicious nodes. The problem is like I pitched using ML to detect malicious nodes and remove them from the network automatically. Um, there's a separate thing for validating like those transactions as well, but um, the problem is these nodes are connected in a network, right? And so if we decide, okay, this node is bad, we need to kick it out, almost all the other nodes have to make the same decision, right? So the nodes have to basically vote and act in a democracy. And we're not talking about people, it's actually computer algorithms like deciding to make the decision. Now, the problem we encountered is if we have a model and we distribute it and it's self-updating and self-evaluating, can we make it deterministic, especially with like deep neural nets? Can the network actually make the decisions as well? And finally, could something like gaslighting occur? Gaslighting being one node basically convinces all the other nodes that another node is bad by taking advantage of flaws in the model, right? So yeah, this was a pain to think about and to do, but essentially what we did was we created a set of scores based on how much network a node is sending, how many messages were rejected by them, and like an evaluator on fairness. And based on the scores, we would like determine like if we should reject one or the other. Now, preventing gaslighting, what would happen is nodes would this was an actual exploit that happened in production, um, where somebody tried to forge messages as if they came from another node and spammed everyone. So we had to add like things like score attribution and like data set attribution to ensure that each message only comes from the set node and things like that. And but yeah, like gaslighting or exploiting a known model is something that can always occur, and it's like a risk you just have to take. Actually, like there's no real way to protect yourself from the risk if the model becomes vulnerable and you use it to take critical decisions. So yeah, like we currently use fuzzing in our model, which is kind of like key rotation, like rotating the model so that flaws will be rotated out and weights and stuff. But yeah, I guess all this talk of malicious nodes is probably why the CEO went crazy and thought we were planning to kick him out, but I digress. Any questions on anomaly detection?
Don't see anything in the chat. Any questions? Yeah, it doesn't look like we have any. At least I certainly don't for this one.
All right. If not, move to generative AI, which is what I've currently been working on these days. Specifically using LLMs a lot, but also experimenting with like some clip and image models, as you can see by these slides, which are actually technically all created by AI, including the text. Fun fact. So first thing is using LLMs to replace human triage. The second is legal LLMs. Then we'll talk about some agent orchestration and then scaling. So this first one is actually what I'm currently working on at AWS. So essentially, like for those that don't know, LLMs, large language models, um, will are basically like able to currently create text from being fed text. And they're able to do so in a way such that a lot of mundane tasks, such as summarization and so forth, are like adequately performed that one would generally use a human for before, either a human or a less convincing model. So I've been tasked with like I was tasked to see if I could replace human triage at AWS, specifically at EBS, with LLMs. And in our problem space, we have over 50 people which are currently on call at one time. And they're constantly just triaging tickets, as in they see a ticket comes up, have to review the logs, take some action or fix something, and then move on to the next one. And 50 people is a lot. Like they could be doing but like more important stuff like coding or like interacting with customers or things like that. And also imagine you're a customer and something happens to your thing, right? Your volume or your VM or something. You really don't want to wait for a human to resolve it, right? Like if something happens and some bot automatically resolves it within a few minutes, like that's obviously way more ideal than waiting like for an hour or like having the human come up and then take another 20, 30, maybe even days to get to it and resolve it. Also, issues once they're resolved often fade, as in the person just fixes it but doesn't tell anyone. And those things keep happening over and over and over again. which means like just more and more people go on call and have to deal with it. Like often these things should be resolved. Um, Finally, we need to reduce MTTR, which is mean time to resolve. This is like a measurement of how long it takes to fix a customer's issue. We want to lower the on-call burden and the overall headcount, which is used for on-call. And so essentially what we were able to do is it created a system wherein we ingest a bunch of ticket data and we use embeddings to essentially like convert each ticket into a vector. We cluster the vectors, find similar vectors, and then we use LLMs to analyze and determine like what was done before. We also have like a bunch of actions LLMs can take by themselves, which are safe. And if those actions correspond with something that was done on the similar ticket, the LLM can just do it, post on the ticket, let the customer know, and fix the problem. And right now, surprisingly, we've achieved a 60 to 70% auto resolve rate, which is pretty huge. A lot of people are freed. We want to get it higher, but there's like a number of issues with like you don't want somebody doing you don't want LLM to do like dangerous things like decide to power off a server or something like that, and there are exploits which could lead to that. But yeah, it's proven surprisingly effective. And and one other thing is like usually like in production when you run a service, you have like what's known as a run book, which is like if something goes wrong, you go to a portion in the run book which is like, oh, if this happens, do this. The problem with these run books is they often get outdated. Like if you push a new change which removes some old features and adds new ones, now your run book is outdated. The old issues may not apply and there may be new ones. What this LLM has allowed us to do is generate always up-to-date run books based on actions that operators take on tickets, right? So if a human ever does like, oh, this is a new issue, they research it and they find a fix and they push it, solving the customer issue. We have analyzers which are analyzing what operators doing at all times and generating updates to run books. So not only will the AI consumers, LLM consumers downstream be able to use that for any new tickets coming, but humans will also be able to use it in case they have to face a problem which escapes the AI. After starting work on this, I was thinking about whether we could make it a production service, have external customers use it as an AWS service or anything like that, like think about it from that angle. Question I got is you need a lot of legal approval and we need to make sure that PII data is not resolved. And I started looking in this space from that and I was like, oh, I wonder if there's something that could automate this entire process for me. So the first thing that I see a question in the chat. I'll get to this in a sec with what we currently use. But So for PII, like the first thing I had to do was I was like, we generate like a lot of artifacts, when we build things, like we put like their names associated with the code you write. There's documents you write which have names and internal things. And yeah, a lot of things when you make public or when you launch in certain regions, like if you launch in California or if you launch in Europe, there are a lot of protection laws around this sort of stuff, like around people's names, people's property, and things like that. And for instance, if you leave a company when you work in Europe, you can request all your data to be deleted, right? And it doesn't mean they delete your code, but all the names and stuff associated with you should be removed. And companies have to comply with this. Similar thing if you're in California, but a bit different in a few ways. So I started working on an open source project called PII Shield with some coworkers and a few people who are big in the open source space for LLM tooling. Which what it does is redacts private information, which is what PII stands for, using things like OpenAI's GPT-4 and other models. Now, the problem we have is like, imagine you have a lot of data, like we were talking to a call center, right? A call center does call recordings. And when you're, on a phone call with the support system, they're going to ask you, what's your name? What's your password? And a bunch of things like that. And you don't want that in your recording. The problem we have is like they generate those so many logs, so much data that if we were to apply LLM processing, it would take millions of dollars, which they did not want to pay. So we decided to use like classical NLP classifiers, which were overtuned for efficiency. And what we do is classical classifiers just try to determine if there's any semblance of any PII data. And we have a few of them, like we have one for name, right, which just focuses on like pure any type of name. And it may be wrong, like you may be talking about a brand, which is not relevant. Or you may be talking about the company itself that they're calling for, which is not relevant. But the idea is we can filter out actually 80% of the text, which has nothing to do with personal information. And then the remaining is processed through the LLM. So instead of taking a few $1,000,000, right, it goes kind of down to a few thousand, which is way more palatable for customers. Not that they've used us yet. They have other misgivings, but we'll get there. Another thing we do is we take smaller models and we fine tune them so that they perform really well for a use case. So GPT-4 for our use cases, right? Like, as I said, could cost millions of dollars if we applied it to everything. A fine-tuned base model, which we can run ourselves or run on the cloud, would likely cost only a like few 10,000s, like probably like 60-ish thousand, which is a lot of savings, and it can perform better. Finally, I've been pitching this to a lot of lawyers at legal hackathons, and they're actually excited to use a lot of the tech, and there are a lot of laws coming in soon which will force them to use this tech. For instance, in California, there's a new blind law which forces things like race and sex to be removed from certain testimonies in order to be able to assess the case in a fair way. The problem is there's like a lot of legal documents generated, right? So they can use something like PII Shield to filter out race, name, and things like that and use them in court without having to have humans to audit like every single piece of writing that comes through and go back and do that kind of thing. Somebody I think asked, what are the current top tools for dealing with LLMs? And that's a pretty big question, because there's like a lot of stuff you can do with LLMs. So PII Shield is open source. So I can show like that is a tool we can use, but we use raw output because we're trying to like make things with the highest efficiency. So mainly we just use Python, and we use like we do inference using this tool called ONNX, which is a high efficiency inference where you can like load a model, and traditionally you would have to do a single inference, but it can do a batch. And this is how OpenAI serves their models as well. I found out through interviewing from there, but didn't accept their offer for other reasons. For this human triage thing, we use something called a technique called retrieval augmented generation, which sounds fancy, but all we do is we use this tool called embeddings. Essentially, it's a model which converts text into a vector space. And the idea is that if vectors are close together, they're similar. And you can train your own embedding model. And in order to do it, like basically what you would need is just a bunch of example sentences. And through encoding all these sentences, you can train essentially a neural net which converts like a given portion of text to a vector space encoding. Yeah, and you have to have like a pre-clustered training set, so it's kind of hard to do just by yourself. But there are a few small data sets you can use out there to create a micro embedding model. So one thing we did with some of the classical NLP stuff is we used LLMs to generate a lot of data, which is pre-clustered. And then what we do is we retrain the classical NLP model, or we train our own embeddings, which are tailored to cluster, which are tailored to like put tokens together, which are semantically relevant to proper nouns or certain types of PI, such as locations, names, phone numbers, IPs, and things like that. Yeah, that experiment failed though. I will say did not end up well, but it was worth a shot. In terms of embeddings for semantically relating proper nouns, but classical NLP worked better. I'll talk about scaling in a sec too. So one thing a lot of people try to do, and one thing I consulted for and also have an open source project for, is AI agent orchestration. And what an AI agent is basically, the idea is like, let's say you want to order DoorDash, and but from a restaurant that doesn't support it, meaning like you have to call them and tell them to deliver you some food or whatever it is, right? But you don't want to go through all those steps. So the idea is you just want to tell an AI, hey, get me a pizza from wherever is close. And the AI figures it out and does it automatically. the reality is that AI agents are brittle. So recently I worked with a founder who was building a product where you could ask them, like, you could ask the AI and be like, their product, you could be like, hey, I'm trying to host an event, book the venue, the food, it's for this many people, my budget is XYZ. And the idea is that the AI would sort out everything. The thing is that LLMs already like are kind of iffy. Like I would say they have like a success rate at following vague rules at about 80-85% at best, and it really depends on which task you ask them to do. And you can improve this to 90-99% ish using some techniques. The problem is, like, imagine you have a chain, right? You ask an LLM to do something, to output content according to a rule, right? And you have a 95% chance of success. But then you need that output to do the next thing, which also has a 95%. And you need that output to do the next thing, which also has a 95% chance. Oh, and by the way, an LLM is coordinating all of this, right? So as you can see, the further you go down the chain, like it's almost an exponential degradation because you keep degrading and the chance of failure keeps increasing, like however low you go down the chain. So one major thing I'm trying to work on and solve right now is preventing this chain degradation using fine-tuned models, but or other classical methods, but it's not easy. And I haven't gotten, like, I've only improved accuracy overall, but it seems right now pretty hard to like utterly avoid chain degradation. So one thing I'm working on though is building like regression analysis, which basically what it does is at each point in the chain, you can checkpoint where you're at and store all the data. And then you can have another model keep evaluating it for regression or anomalies, what I talked about before. So we can use the anomaly detection here to detect anomalous outputs within the chain. And that can kind of act as like a retry mechanism or a failsafe to help catch chain degradation and prevent it from going further or even trying to retry and fix it somehow. It's not a silver bullet though. And so there's this idea of just hand curated chains, right? Instead of having an AI plan the whole event, right? Maybe a human could write a specific portion, like an interaction of how an LLM would go about getting caterers, for instance. And let's say this has, a pretty high success rate, like the overall chain success rate is 95%. Well, when you invoke this in the parent flow of scheduling an event, it improves the overall success rate instead of each portion of the subchain being prone to breakage. So that is like something that is an option too, but not a lot of good tooling exists for hand curated chains. So I'm trying to work on open source tooling for this. There is LangChain, which is one very popular tool that many people use, but I absolutely hate LangChain. Not with a passion though, but I do despise it, mainly because it has like a lot of magic and it's impossible to debug, and you can't do like things easily, like anomaly detection, like what I mentioned earlier. And chains created in LangChain tend to degrade. So yeah, trying to build something better, hopefully, that people can use, or at least for my own sanity that I can use. But yeah, it would be helpful for anyone trying to create complex LLM based workflows. Finally, touching on the other comment on what tools are often used for LLMs. Beyond experimenting with the GPT-4 API and LangChain, which despite me hating, it's like a very good way to like learn what people are doing and to try out things. So I would recommend it. However, none of these things scale too well. And if you try to use them in production and you try to serve like, hundreds of like requests per minute, hundreds of thousands of requests per minute, sorry, it's just going to fail. And right now there's a whole GPU shortage too for these. So it's just like literally impossible to even run, no matter like, unless you have like, gold coming out of the sky or something. I don't know. So one major thing is caching. You can cache a lot of generated responses, and you can also use semantic models, like I mentioned before, using embeddings or something like that to cache. So it's an intelligent cache instead of just being like, oh, does this content match exactly? If so, give the right output. No, you can semantically cache information and use pre-generated output if the semantic match is close enough using embeddings. That's pretty cool. Then we have batching. One thing is when you load a lot of modern LLMs into memory and you perform one inference, doing multiple in parallel actually goes through the same propagation. So batching is like a huge thing that could be done to improve the speed and queuing stuff in front of it. There's also a UCSC researcher working on something called Spike GPT, which looks to actually trim the models that don't get activated as much and not even to load them in memory. So it's a very highly optimized form of the GPT transformer architecture. So I would recommend looking that up and reaching out to them if you really want to get into the space of making GPTs work and making custom GPTs work in production. I haven't tried it out yet. It's on my to-do list. But based on the papers, if it's as promised, like if we can train some specialized smaller submodels based on that architecture, it could result in like a dramatic reduction in cost. So yeah, smaller submodels is like, I think the way things are going to go in the future, like, because you can curate a very high quality subset of data and use that to train your model. For instance, I talked to this team at Microsoft who's working on some similar things, what I was doing with PII Shield, but for a different use case. And with just 200 overall samples, they were able to use it to generate a bunch of data and train a model using the GPT architecture and transformers. So it's still a large language model. But they were able to train a model that outperformed nearly everything and was like 1,000x cheaper to run compared to anything that was within 10% of its performance. Yeah. Lastly, classical ML shortcuts, right? Like if you don't have to run LLMs, don't do it. Run classical ML, which is much easier to scale instead. or use it for a subsection. Um, yeah. And I think that's about it. Um, Happy to take any questions. If anyone's interested in any of the work I do or wants to learn more, get involved, you can feel free to reach out to me. I'm in the SEAI Discord as well, so you can ping me there. But I'll also post my LinkedIn in the Discord or here if
Sounds good.
anyone add me or reach out. But yeah,
Perfect. Any questions? Uh, cool. All right, then we'll call it a wrap on today's speaker event. Thanks, Janesh. Thank you so much for coming in and talking to us today.
all right.
We'll keep in touch, and for everyone else, there's no meeting next Tuesday. It's Halloween, so have a good time. And yeah, we'll be back with Skyjam next Saturday. So yeah, we'll see you all there. All right, guys. I'm gonna stop the recording.